Mars, the red planet, fourth rock from the sun. For centuries, we humans have gazed at our neighbor and imagined an alien world. And as human technology advanced and telescopes brought it closer, we began to see signs of life.
As the 20th century began, mainstream credentialed astronomers were looking at Mars, thinking that they saw evidence for a society, a civilization on the red planet.
We Earthlings braced for contact. If there was life on Mars, what form would it take? We set off into space to find out. But as we approached the red planet, we discovered a new mystery.
All the elements needed for life were there, so what happened? Where did everybody go?
Mars is almost Shakespearean, a beguiling world. It's tricking us every way.
So Mars, dead or alive? Some think Mars was home to an ancient civilization.
There was at one time intelligent life on Mars, and they built something.
But the evidence continues to elude us.
If there's life there, we'll find it.
Across the globe, the race is on for the greatest discovery of all. Join skeptics and believers alike as we try to answer the age-old question, is there life on Mars? If you're planning a trip to the planet Mars, here are a few travel tips to help make your journey as comfortable and rewarding as possible. All in all, the expedition will take about 2.5 years, including approximately 12 months aboard your interplanetary spaceship. So make yourself comfortable. Plan your provisions carefully. You'll need to bring plenty of water. At this time, there's no liquid H2O anywhere on the planet's surface. You'll also need an effective spacesuit and a sufficient supply of breathable air. Finally, remember, Mars is about 1.5 times further from the sun than Earth, which makes this a cold world. The temperature can drop to a chilly -130 degrees Fahrenheit. So dress warmly. These technical issues aside, Mars has a lot to offer. It is home to the largest known volcano in our solar system, a magnificent Grand Canyon, and breathtaking deserts. For those of you interested in culture, a visit to the notorious Face is a must. We know you have a choice, so thank you for choosing the planet Mars. All in all, without ever setting foot on Mars, we know a lot about this distant world. But what we don't know is, what about life? When the first astronauts arrive on Mars, who or what will they find? Will aliens be there to greet us? Or is no one there at all? Inquiring minds want to know, is there life on Mars? It's a big question, and a fundamental one, because really, it's synonymous with the question of, are we alone in the universe?
If we go to Mars and find evidence that there was life on Mars or is life on Mars, then we'd be able to say that in our own solar system, life appeared twice. And I think that would be convincing evidence that the universe is full of life.
Discovering life on Mars could also reveal a lot about our own existence.
We have one kind of life adapted to one planet, even with all of its diversity. So looking at the way other planets may have given rise to a phenomenon that we would recognize as life can enable us to understand our own kind of life in a deep and fundamental way.
The stakes are high in the game of life, and Mars may hold the key.
If we're going to find proof of life on Mars, we're going to have to go to Mars to get it.
But getting to Mars isn't exactly easy. The Apollo astronauts took about 2 days to get to the moon. A journey to Mars one way is roughly 7 months. Mars takes about twice as long to orbit the sun as Earth. So a space mission has to plan departure when the two planets are close. The challenge of bringing a mission back is incalculable in complexity. Just one of the reasons no manned mission has ever been attempted. But that's exactly what Dr. Robert Zubrin of the Mars Society wants to do. Bob Zubrin, an astronautical engineer with 15 years of experience in the space industry, has been planning a trip to Mars for the last 2 decades, and he's come up with a novel way to do it.
If we want to go to Mars, we need to travel light, live off the land.
What makes a Mars mission so prohibitively expensive is the amount of mass, mostly rocket propellant, you have to send there and back. Instead, Dr. Zubrin came up with the following plan. Take supplies enough to get there, then make what you need on the planet.
There's 3 things we want to make on Mars. First, most importantly, propellant. After that, water. And third, oxygen. We can make all 3 with this machine.
Here's how the machine works.
The Martian atmosphere is 95% carbon dioxide gas. We pump that into the reactor. We mix that with a little bit of hydrogen. You can make that reaction produce either methane or carbon monoxide or any mixture of the 2. And water.
The methane and carbon monoxide mixtures can be used as rocket propellants for the return trip to Earth.
The water, we could keep the water and drink it, or we could electrolyze it into hydrogen and oxygen. The oxygen that comes off, we could use as breathing oxygen, we could use as rocket propellant oxygen. That's how the machine works. It makes your fuel, it makes your oxygen, it makes your water.
And leaves enough room on your spaceship for food. All in all, it looks simple enough, and it's not just theory. Working with simulated Martian air, Zubrin has spent years testing and refining the technology.
This is a subscale methane, carbon monoxide, oxygen rocket engine. It all works. It works great. These are great propellants. We start them right up with a spark plug time after time.
In a way, Zubrin has done all this to make a point. Current thinking is that it is too expensive and dangerous to send a manned mission to Mars. Instead, the international space community has deployed a range of unmanned robotic explorers on and around the planet. But Zubrin points out using robots to do field research leaves a lot to be desired.
Okay, we can send robots to Mars. And I support sending robots to Mars. I think we ought to send a lot more robots to Mars. Okay, robots can make all kinds of discoveries. They can give us all kinds of data. They can image the surface of the planet and possibly identify interesting targets for exploration. But they won't tell us the answers that we need to know. They won't tell us if there's life on Mars.
So does Zubrin expect to find life on the Red Planet?
I think that a naturalistic view of the universe would suggest that the Earth is not special, and that if life can evolve here, it could evolve elsewhere where environmental conditions are similar. And if there's life there, we'll find it.
But perhaps there's an easier way to find out. The answer could already be here on Earth. Every year, hundreds, maybe thousands of aliens come to our planet. Most arrive quietly and go unnoticed. Others enter the atmosphere in a blaze of glory. These aliens are meteorites. For centuries, these rocks from the sky were treated as curiosities, often ending up in local museums or private collections. But the information meteorites contain is so valuable that today, the scientific community sends out search parties to gather them. Although meteorites fall randomly all over the Earth, one of the most popular hunting grounds is Antarctica. Every year, scores of scientists take their lives in their hands and head to the frozen continent. The teams conduct a systematic grid search of the icy landscape, looking for telltale dark shapes against the blue-white of the ice. It was on an expedition such as this that a meteorite was found that would shake the scientific community to the core. The team sent it to a special facility at the Johnson Space Center in Houston, because this is where NASA keeps the aliens. 84001, or the Allen Hills meteorite. The strange green rock was kept under strict quarantine. It was processed, examined, and rigorously interrogated for information about its home world. It took 10 years, but investigators finally got the truth. This rock was from Mars, and it had a secret to tell.
Today, Rock 84001 speaks to us across all those billions of years and millions of miles. It speaks of the possibility of life.
So what was it the rock told us? We'll come back to that a little later. But perhaps the best evidence of life on Mars is not hidden deep in an alien rock. There are some who believe a vital clue is staring us right in the face. Richard Hoagland has dedicated his life to examining imagery transmitted to Earth from various Mars orbiters. Surveillance systems that have circled the red planet for over 30 years now. In the first pictures that the 1976 Viking orbiters sent back from the planet's surface, Hoagland saw something that blew his mind.
I looked at this and it was like, oh my God. This thing had symmetry, it had proportion, it looked like a statue.
Hoagland is referring to this remarkable image, a face-like structure the size of multiple city blocks. And Hoagland thought he saw more. Other structures surrounding the icon, eroded by time. To him, it looked like the ruins of a monumental city.
It looked eerily like an aerial photograph taken flying over Giza, looking down at the pyramids on the Giza Plateau. It looked like a ceremonial complex built by somebody with a huge sphinx-like creature staring up into space from the sands of Mars at the telescope orbiting 1,000 miles overhead. Somebody was down there, and they cared enough to leave the very best.
Needless to say, Hoagland's theory raises more than a few eyebrows. But did life on Mars ever exist? Was there once an ancient civilization of alien life forms? And if so, where did they go? Believe it or not, the idea that Mars was occupied by a race of intelligent extraterrestrials was not the creation of science fiction, but science fact. In the early days of humankind, Mars burned faintly red in the night sky, leading some to equate it with a mighty god, naturally, the god of war. But then astrologers, using a new contraption called the telescope, determined that those lights in the sky might be planets, much like ours. This meant there might be other civilizations, other life forms out there. And Mars was about to become the star attraction. Thanks to Italian astronomer Giovanni Schiaparelli. In 1877, Schiaparelli trained his telescope on the Martian surface and observed the existence of canali. By this, he meant natural channels. But due to an unfortunate translation, these channels became canals, which implied a man-made phenomenon. To fully understand the impact of this, consider that only a few years earlier, human engineers had completed the awe-inspiring Suez Canal. It defied nature and geography by linking the Mediterranean and Red Seas. It was considered the latest wonder of the modern world. Whether or not Schiaparelli believed the canals to be made or natural, the word itself sparked the public imagination. If there were canals on Mars big enough to see from Earth, really intelligent beings must have built them. The rumor was dramatically compounded by an American astronomer named Percival Lowell. Lowell was a highly respected man of good society who had a profound love of astronomy. He developed a fascination with the canals of Mars and sat up through the nights observing the red planet. And what Lowell thought he saw in the wee hours was a dying world crisscrossed by constructed waterways. Perhaps, he wrote, creatures short on water have built an irrigation system that circled the planet. By the turn of the 20th century, the idea that Mars was occupied had hit the mainstream media. New York Times headline, 1911, Martians build 2 immense canals in 2 years. Martian civilization was usually perceived as being ahead of us in evolution. And each earthbound nation projected onto Martian society the diverse vision and fears of its own future. In this 1924 movie from Russia, Mars is portrayed as going through a proletariat revolution and ending up successfully communist. But many thought that Mars was dying, And some said it was only a matter of time before Martians tried to contact us. And so, some thought, they did. Through another new technology.
This is Seth Shostak. Go ahead, caller.
Radio. Astronomer Seth Shostak takes up the story.
It goes right back to those early radio pioneers, and none so directly as to Nikola Tesla.
One of the most brilliant electrical engineers of all time, Nikola Tesla, was the first to claim someone from beyond this planet was trying to get our attention. In 1899, Tesla was experimenting with an electric invention that essentially acted as a large antenna when he noted something strange. Repetitive signals which were substantially different from the signals he had noted from storms and earth noise.
And it's only natural to imagine that he would ascribe this to some sort of intelligent beings, because as far as Tesla knew, only transmitters could make radio sounds. So he naturally assumed that if he heard something, somebody was broadcasting it.
In fact, Tesla was probably mistaken, as Shostak often gets to explain on his weekly SETI radio show.
Well, we don't know for sure what Tesla heard, but most likely it was something that we call whistlers. These are just distant thunderstorms, lightning discharges that produce natural radio waves that get distorted by the atmosphere as they propagate around the Earth and make a sound that kind of sounds like a whistle.
Modern science may have an explanation, but in a way, Tesla was ahead of his time. The idea that you could send signals from one planet to another made sense and inspired subsequent radio enthusiasts to listen for signals from outer space.
A guy by the name of David Todd realized that in 1924, there was a real opportunity to listen for the Martians. And the reason was that in 1924, you once again had one of those circumstances where Mars and the Earth got close to one another. So he organized an effort to get people to stop transmitting for 5 minutes every couple of hours so that people with the right equipment could actually listen, and this included the military, to listen for signals that might be coming from Mars or some other planet.
But whatever the message might have been, it seems we humans didn't get it. At which point, the Martians turned nasty.
Ladies and gentlemen, we interrupt our program of dance music to bring you a special bulletin from the Intercontinental Radio News.
In 1938, Mars attacked. Turns out it was apocryphal, an imaginative radio play based on the H.G. Wells book, War of the Worlds. But many believed it and thought Earth was under imminent threat from aliens.
Now, mind you, it wasn't so unreasonable. I mean, there were places that really were being invaded at the end of the 1930s, after all. So the mindset of the public was kind of attuned to the idea of hostile forces coming in and taking over.
And sure enough, they came. Martians, great and small, came out of the skies and landed in our movie theaters. Sometimes they looked like giant insects. Mostly they seemed suspiciously human-like, and they came in a bewildering variety of shapes and sizes. They had laser guns, vaporators, evaporators, death rays, and deadly kisses. They wanted gold, weapons, earth women, and human blood. One thing's for sure, they were very rarely friendly. Next thing you know, real flying saucers were being reported from San Fran to Timbuktu, and the phenomenon of alien abductions was born. The world, it seemed, had gone crazy for extraterrestrials. For all its downside, the popular imagination paved the way for mankind to make that giant leap. In 8 years, the U.S. built a transport system and became a spacefaring people. Perhaps we were determined to bring democracy to the communists on Mars. In fact, we only got as far as the moon. And while there were no aliens up there, you might argue that if we could make the trip, then extraterrestrial life capable of interplanetary flight was at least a possibility. So what about Mars? As our technology got better, we sent a robotic scout to the Red Planet. The landing was a success. The robot touched down, turned on the camera, and we finally got a good look at Mars. It wasn't what we expected.
How disappointing after centuries of assumption that Mars was inhabited, that it had cities, it had canals, and the reality was that it was just this terrible, awful, dead-looking place.
Ladies and gentlemen, we regret to inform you, Mars is dead. Or is it? Mars may be unoccupied now, but if we're to believe Richard Hoagland, the red planet once hosted a magnificent civilization. Hoagland is the principal investigator of the Enterprise mission, a loose collection of scientists, researchers, and Mars enthusiasts. They've spent years trying to prove this extraordinary theory. For Hoagland, it boils down to this.
If I had one catchphrase to describe the whole problem of convincing scientists that there is really an ancient civilization on Mars, it would be, it's the geometry.
Take the face-like structure from this 1976 Viking orbiter image. NASA claims it's a naturally occurring rock formation. Richard Hoagland thinks there's more to it.
If you actually look at proportions, where the mouth is, where the nose is, where the eyes are, they conform to commonly accepted statues and representations of human forms that go back literally thousands of years.
And Hoagland has found what he believes to be a highly complex geometric relationship between various structures centered around the face. Hoagland claims that the layout of this region, named Cydonia, is similar to what we see in ancient ceremonial complexes on Earth.
There are alignments, there's parallelisms, there's right-angle rectilinearity. They also appear to have a specific geometric relationship to the face, to another massive structure down here, to other structures.
To prove his theory, Hoagland and his colleagues have applied a series of computer image analysis programs, looking for, well, basically things that don't match the surrounding landscape. And the face and a couple of other structures register as anomalies, implying, he says, artificial constructions.
This is the real image, and this is the fractal representation. And again, it's the signal strength is basically...
Strictly speaking, a computer will find whatever you program it to look for. It doesn't actually determine whether or not the artifact is natural. But Hoagland claims there are some things you can see for yourself. Take this pyramid, an apparently perfect tetrahedral form with an accurate apex and sharp angles.
This unquestionably had to be made by someone because nature does not produce this kind of structure. If we were to land someday, find the entrances to this thing, walk inside, because if the exterior is preserved in this extraordinarily pristine form, imagine what waits us on the inside.
But if there was a civilization, what happened?
That's where things get interesting, but that's where we obviously cross the line from science to speculation. We have no ground truth, unfortunately.
So why isn't NASA all over this? Hoagland thinks the government is hiding something.
I believe there's a cover-up. Call it a conspiracy, if you will, except they're not called conspiracies, they're called policies.
And why? Well, according to Hoagland, it goes back to an obscure Brookings Institution study commissioned by NASA and published in 1960.
There is a section devoted to the implications of NASA's discovery of extraterrestrial life. And the document recommended that if we were to discover, i.e. NASA were to discover evidence of extraterrestrials, that it should be basically kept secret because it had the potential at the limit to destroy civilization.
The argument seems to be that where a civilization comes into contact with one more technologically advanced, that civilization's in trouble. So does this mean the government is covering up aliens to prevent a societal meltdown? It's a bit of a stretch when you consider that all the Brookings report actually suggested was that we should do more studies. Hardly sinister stuff. Seth Shostak thinks there's a fundamental flaw in Hoagland's cover-up theory.
Well, doggone it, if the aliens are really here and they're really advanced and they're really malevolent, as they could conceivably be, then it really doesn't matter what the government does it? This is Bambi meets Godzilla, and Godzilla's gonna win.
This from someone who believes there's life beyond Earth. Shostak works for an organization that operates on the assumption that not only is there life out there, some of it has technology. This is the Allen Telescope Array, built and operated by the University of California at Berkeley and the SETI Institute. SETI stands for the Search for Extraterrestrial Intelligence. It may seem out there, but SETI is an entirely scientific operation, manned by astrophysicists, engineers, and planetary scientists. Their objective is simple.
It's really easy to send signals between the stars. That's the bottom line fact. There might be thousands, millions, or more societies that are sending information from one star system to the other. Why not look for it?
SETI is essentially eavesdropping on the universe in an attempt to pick up a signal from outer space. To do this, SETI uses highly sensitive radio receivers that scan systematically through the billions of star systems in our universe. It's like scanning through your car radio dial as you travel cross country, but on a cosmic scale.
Now, what kind of signal are we looking for? We don't care. Looking for the message requires a different kind of technology that we haven't built and won't build until we find that they're on the air. We're just looking for a signal that tells us, hey, their transmitter switch is on.
It may seem like looking for a needle in a haystack, but astronomy has made enormous progress in identifying the stars and planets beyond our solar system, which, combined with ever-improving technology, allows SETI to search with more precision. The motive, however, is as old as mankind itself.
We're trying to look for something that would show that, you know, we're part of a bigger picture. We're not just a little bit of chemistry run amok on this small little world tucked away in the corner of a nondescript galaxy in an enormous universe.
So the million-dollar question, of course, has SETI made contact?
In 1997, we picked up a signal using a telescope in West Virginia that looked like the real thing. And we got quite excited to the point where everybody was glued around the computer monitors just looking at what was going on.
The signal had all the qualities SETI looks for in an alien contact. It occurred on a very narrow frequency. This is key because while nature produces radio waves aplenty, they are like broad static across the dial. This one was emanating from a specific location in the cosmos. Throughout the night, scientists were on the edge of their seats trying to pin down the source.
I realized that the world from that day forward will really not be the same. I was very nervous, actually, because I didn't know what the consequences were going to be.
It took 3 days, but the engineers and scientists finally identified the signal, and it wasn't alien.
As it turned out, the signal was due to a European research satellite, the SOHO satellite, the signal of which had just gotten into the structure of our antenna. And that was a bit disappointing.
In conclusion, then, the industry experts, SETI, have not yet found any evidence of extraterrestrial intelligence.
As of now, one thing you can say, and that is we have not conclusively proven the existence of any life, intelligent or not intelligent, beyond the bounds of Earth.
And what about Mars? Martian monuments aside, you'd be forgiven for thinking that 30 years of remote observation has done nothing but confirm our nearest neighbor is dead. But in fact, life on Mars has begun to make a comeback. It's all about water. When NASA scientist Chris McKay saw those 1976 Viking images of a dry, barren Mars, he was intrigued.
I remember the overwhelming impression I got was the lights are on, but nobody's home.
What McKay is referring to is what he poetically calls the ghost of water past. He's offered to meet us in the Mojave Desert to explain.
There's no water in this lake bed now, but the geology, the surface of the ground, shows evidence that there was water here. And that's what we see on Mars. We see dry lake beds. We see river beds that have no water in them, but clearly did at one time. And this is the evidence that Mars had water. And it's that water that's of interest to us from a biological point of view.
Although, in fact, the Mojave gets a whopping 5 inches of rainfall every year, Dr. McKay uses this desert as a near waterless zone to conduct experiments relevant to his theory about Mars. And life, it seems, can thrive nicely in these conditions.
We find microscopic life, microscopic algae, that have learned to survive under dry conditions. This organism, this algae, is the dry version of pond scum. They wait out in the dry for months, maybe years, and then a rain comes and they very quickly set up shop and do their biological thing, and then it gets dry and they shut down and wait again.
Dr. McKay certainly isn't claiming that Mars is populated by desert algae, but he thinks the odds are in favor of past life.
If we were to imagine what would the last Martian have been like as Mars went from a fairly wet, Earth-like environment to the dry desert that it is today, it would have been probably an organism like this.
Microbes? So much for the Martian monsters of the silver screen. But microbes bring us full circle. The fact is, some scientists believe we've already found life on Mars. And it's all because of mysterious clues in a Martian meteorite. Turns out our favorite Martian may be more like our favorite microbe. The 1976 Viking mission to Mars was a triumph of modern space exploration. But one unexpected bonus was information that could be used to further study our alien visitors. The unidentified meteorites sitting in cold storage on Earth.
Well, we've had meteorites we've known were meteorites for 100 years, but we didn't know they came from Mars until Viking landed and measured the gases in the atmosphere, and scientists studied the gases in these meteorites and showed that they were the same.
But how does a Martian rock get to Earth? Scientists think that some explosion, probably caused by the impact of an asteroid hitting Mars, blasts a rock off the planet and into space. It then hurtles around our solar system until, if it's very lucky, it gets caught by the gravity of our blue-green planet and plunges to Earth. Imagine the odds. For NASA scientist Dr. Everett Gibson, this event began a remarkable voyage of discovery.
For one to have life, you have to have the presence of water, you have to have the presence of carbon, you have to have an energy source, and you have to have geological processes. All of these four fundamental things are seen within the Martian meteorites. So, the conditions could be right for life to exist on Mars, perhaps in the past.
And it seemed the NASA team was about to prove it. Thanks to that odd little meteorite, 84001, from Mars.
600 million years after this rock was formed in the crust of Mars, you get water percolating through the rocks, saturated in carbon dioxide from the Martian atmosphere. As the water basically evaporates away, it potentially leaves the carbonate behind.
So the meteorite confirmed that Mars had once been wet. But there's more.
The carbonates contain organic matter. The carbonates contain an iron oxide mineral, magnetite.
Here on Earth, magnetite, essentially magnetic crystals, are often produced by microscopic life forms. This was getting exciting. Using the most powerful microscope at their disposal, the investigators now looked even closer and got the surprise of their careers. They saw what looked like minute worm-shaped structures. Quietly elated, the scientists were cautious.
We said one explanation could have been biology operating. Could have been the signatures of something like a life process.
So was this finally confirmation of life on Mars? Well, from the moment they were announced, the microbes have been controversial. Critics say that the carbonates, organic matter, and magnetite crystals can be explained through other non-life processes, and many believe that the worm-like structures are actually clumps of a coating material used to examine the sample in the laboratory. Still, others point out that the rock could have been contaminated at any time, perhaps when it was lying around for thousands of years here on Earth. Nevertheless, the possibility of ancient Martian bacteria raised the ante on life on Mars. If once upon a time Mars was warmer and wetter and had some early form of microbial life, did it survive, thrive, and grow up to build like an Egyptian? Well, it's a nice idea, but seems unlikely when you consider that conditions on Mars are dry, radioactive, and extremely cold. How could anything survive in this hostile environment? But we could be underestimating the nature of life itself. Microbial life, that is. Believe it or not, astrobiologist Penny Boston is searching for life on Mars by dropping deep into this heart of darkness. This is a lava tube. a subterranean cave formed by underground lava flows during volcanic eruptions that occurred thousands of years ago. And Boston has someone she wants us to meet.
Sometimes they're in crevices. Sometimes they're kind of hard to see.
Is this when the scary monster reveals itself?
Ah, there's one.
Actually, no. This is an extremophile.
We're looking for what we astrobiologists call extremophiles in this environment, and that means that they're organisms that are living in very difficult conditions. In this particular case, these organisms are living in a very cold cave right around freezing. They are making their living without benefit of sunlight, and there's almost nothing to eat in this cave.
In recent years, scientists have discovered tenacious microorganisms living in all forms of extreme environments. So if on Earth, why not on Mars?
We think that Mars is covered with lava tubes. We believe that by looking at organisms that live in these extreme circumstances on Earth, we can learn a lot about what to look for on Mars, and that similar Martian organisms may be able to persist on Mars in places very similar to this lava tube.
To find out, Dr. Boston has created her own little Mars environment biospheres, essentially exposing a range of microscopic Earth life forms to various elements to be expected on Mars.
They have been subjected to Mars-like levels of high ultraviolet radiation and Mars-like temperature cycles. We have given them atmospheric compositions from very low levels of carbon dioxide with nothing else to perhaps 1/10 the density of Earth's atmosphere, and tested them under those conditions.
And so far, she's isolated 36 different strains of organism that thrive quite happily. So in theory at least, life could survive the harsh conditions of Mars, except for one problem.
There's one thing for sure that we know, and that is that all forms of life on our planet require liquid water. We don't know if that's going to be true on other planets, but we think that where there's going to be life, there's going to have to be water.
This simple fact has helped scientists in the 21st century refine the search for life on Mars into a comprehensive strategy. Dr. Jim Garvin is chief scientist at Goddard Space Center and a veteran of NASA's Mars exploration program.
NASA uses a term, follow the water. Following the history and record and abundance and inventory of water is a wonderful way to search for something as tough, perhaps elusive, as life.
We already know that Mars was wet in its ancient past and has reservoirs of ice in the polar caps. But using remote sensing technology, NASA has found what could be evidence of a modern water cycle.
We've discovered tens of thousands of hillside gullies that clearly released a fluid, likely liquid water, in the extremely recent geological past.
They've also discovered that Mars has a vast underground reservoir of ice, spanning about 30% of the planet.
The reservoir of water under the surface may include liquid zones. They may be liquid under the ice caps, they may be liquid hundreds of meters deep, they may be liquid tens of meters deep. All that points to a modern liquid water cycle on Mars.
Where there's water, there could be life. And when it comes to the question of life, Dr. Garvin is a believer.
Absence of life in all senses of the word throughout time on Mars. Is that a possibility? I actually believe not. All the right building blocks, initial conditions, the same that we think persisted in early Earth, must have been at Mars. So, the tale of two planets. Where do they diverge?
It is this that drives the international space community to take aim at Mars. Over the past 30 years, dozens of unmanned missions have been launched. But the Red Planet has become something of a Bermuda Triangle, with roughly 2/3 of all missions ending in failure. Given the danger and high ticket price, plans for a manned mission have been delayed for decades. For Dr. Bob Zubrin, it's a dream that he refuses to let go.
NASA had plans to send people to Mars by 1981. Those plans were credible. We should have been on Mars a quarter century ago.
Bob Zubrin is president of the Mars Society, a coalition of scientists from all walks of the international space community. The Society has been lobbying Congress, NASA, and the government for years, determined to keep Mars exploration on the radar screen. And Zubrin has been practicing. The Mars Society has set up Mars analog habitation modules in the deserts of Utah and the remote landscape of Devon Island in Canada.
What we're doing at these stations are really what someone would call operations research. We're trying to find out what field tactics and techniques would be most usefully applied on Mars, what technologies would be most useful to the crew.
And Zubrin has more in mind than a quick trip across space. He plans to colonize the planet.
We're going to Mars because Mars is the planet that has on it the resources needed to support life, and therefore potentially someday human civilization.
For Zubrin, Mars is the new frontier.
Whether or not there has been life on Mars, whether or not there is life on Mars, there will be life on Mars. And it will be us.
Zubrin isn't the only one with plans for the Red Planet. Dr. Chris McKay champions another idea, essentially to kickstart the biosphere.
If we go to Mars and find that there is no life, then I say we might as well move in.
And in the case of Mars, that begins with warming up the planet.
Well, we know how to warm up planets. We're doing it on Earth.
By introducing preferably non-harmful greenhouse gases into the Martian atmosphere, we could start a chain reaction.
The effect of these gases would be to melt the ice, bring back the atmosphere, and restore Mars to the conditions it was billions of years ago.
Right, but if we're going to live there, we're going to need oxygen. Well, Chris McKay has that covered.
These organisms are known as cyanobacteria. It's a type of algae, a single-cell type of algae, that has a very long history on Earth. These were the organisms that first made the oxygen. And these organisms could do the same thing on Mars. Send them to Mars and ask them to change the world.
Cyanobacteria, the planet changers.
These are the little green men. They're not men, but they are little and they are green.
But wait, what about the pyramids? The supposed signatures of an ancient Martian civilization. What if the guys that built the face are coming back? Mars. Could that enigmatic face in the hills of Cydonia really be a calling card from a lost civilization? Ironically enough, we might pick up a clue at the World Science Fiction Convention in Southern California. No, we're not looking for Martian monument builders. We're here to meet astronomer Phil Plait, a scientist on a mission to provide participants with a healthy dose of science fact. Today, he's taking on the face on Mars.
Just so we're clear on this, it's a rock that looks like a face. And it's not even that good of a face. It looks like he's got, I don't know, Isaac Asimov.
Phil Plait is the creator of Bad Astronomy, a website and book dedicated to debunking what he calls pseudoscience. For him, the solution to this Martian riddle is elementary.
There's a trait called pareidolia, and it is the tendency to see faces in random patterns, and we see this all the time. You can find lots of features on Earth. I once saw Lenin in my shower curtain. It was just a water stain in my shower curtain, but man, did it look like Lenin.
Why do humans do this? One possible explanation for seeing faces in random patterns is that it's a survival technique going back to infancy. Unresponsive babies are more likely to be ignored or abandoned. So to make sure he gets mom's attention, a baby will seek out the image of a human face and gurgle adorably. Whatever the reason, Phil Plait thinks we can't always trust the evidence of our own eyes.
Our brains don't like random patterns. They want to find some sort of real pattern in the noise, in the randomness, even if it's not there. And so you can just take a collection of dots and you might see a head, or you might see Jesus in it. But that's just your brain trying to find a pattern desperately in something that is patternless.
If you take a closer look at the Martian terrain, the planet explodes with faces. Face-like patterns, Plait insists, not monuments to ancient civilizations. Richard Hoagland, the leading advocate for the theory of monuments on Mars, has countered this argument for years. He insists his theory is based on more than just a pretty face.
If I had to stake my entire almost 30 years now looking at this, that there was at one time intelligent life on Mars and they built something, I would say the geometry of Cydonia is now trillions to one against it being chance, and in any any man's or woman's science, when you have that level of odds in your favor, you can say with relatively good backing that it's real.
Fair enough. Let's ask the scientist. NASA scientist Jim Garvin has this to say about geometry.
It is possible to construct geometric patterns between anything. There's an infinite number, in fact, of different affine geometric patterns between this feature and that feature and this feature and that feature. To read one as being the answer to this particular small patch of Mars is extremely challenging to me and to the science community.
But what about those interesting pyramids and tetrahedral-shaped landforms? Just the wind, says Garvin.
If the wind is blowing one way for a while, and the next season it blows this way, and the next season it blows this way, and the next season it blows this way, what happens? Over time, if that's the consistent pattern of the wind, sandblasting, in this case a hill about 10 blocks in scale, you can produce landforms that remind one of pyramids.
Similarly formed natural structures called yardangs are found in the dunes of Egypt's western desert. In short, Dr. Garvin sees the Cydonia region as a natural landscape shaped by the forces of erosion. So what about the face?
When I look at this picture on Mars, I see positive relief landform, a hill of the scale of multiple city blocks, very similar to tens of thousands of others on Mars.
But Dr. Garvin insists you can't prove anything with a two-dimensional snapshot. In order to analyze the structure, he's created a 3D model of the landform by combining topographical data with a high-resolution 2D image. Now he is able to observe the face as if he were flying around it in a helicopter. And from this height, the Sphinx dissolves into landscape. No eyes, no mouth. Remarkable only because this is a hill on another planet.
There's a lot of different interesting ways to look at this feature. The simplest way is the natural way. And that's always worked well in science.
Just one more thing. Why doesn't NASA send one of its robots to take a look? Well, considering the enormous cost and the physical challenges of dropping a priceless asset such as a Mars rover, the target must surely be chosen with careful consideration on the basis of scientific priorities.
Why would we consider this a first priority? And that's the question I leave you with. We're looking for our origins in the history of life in the universe. And there is no evidence that that has a bearing on that question today.
In the end, it's up to you to believe in the magic of ancient monuments or the world of modern science. So Mars. For centuries, the red planet has kept us guessing. First, it was home to an advanced civilization and the Martian invaders of our silver screen. Then, it was a cold, dry, barren planet. And now, it offers the possibility of life, with mysterious clues in a Martian meteorite and the suggestion of water once thought long gone. But is there life on Mars?
I think odds are we won't find life. There's no evidence, so I'm not going to bet my house either way.
But the desire to know drives us ever closer to an answer that may also hold the key to our very place in the universe.
We live in space as small, minuscule amounts of the matter that is the bigger space. The more we understand the history of life in this solar system, in this universe, the more we understand our own life and our own destiny.
It's been 30 years since a human last set foot on another world. If space exploration is to become a reality, not of the past, but our future, perhaps it's time to set our sights on Mars.
There's some moments in history where you have the capability of doing something important, and I think that this generation has the capability of finding out whether we're alone or not.
Either way, it's something we need to know.
If we search the universe and we find no evidence of life, we should start taking seriously the possibility that life on Earth is unique, really unique, and that in a very real way, the contribution of Earth to the rest of the galaxy, to the rest of the universe, may be life itself.
Alone in the vastness of space, perhaps even the worst of our Martian nightmares is better than galactic solitude. one thing is certain. Our best hope for finding out if life exists in the universe lies on our sister planet, the Red Planet, the remarkable neighbor we call Mars.